So in 2.1, we're going to talk about intercepts and symmetry. But before we get there, we're going to talk about the graphs that lead to those things. And in particular, we're going to talk about a linear function and a quadratic function. So for each one of these functions, we call what's called a parent function, which is the basis for the transformation or the different graphs we get from that function. In the case of a line or linear function, we have the parent of y equals x. And in the case of a quadratic, the parent is y is equal to x squared. So what you need to know is the exponents on each of these. The exponent here is clearly seen to be 2. However, this one's not written, but it's understood to be 1. And when we write this one in standard form, it looks like this. It's ax plus by is equal to c, where you're still focusing on just the x variable of 1, but you've added these other variables in. Over here in standard form for a quadratic, it is ax squared plus bx plus c is equal to y. And so again, same concept, but now you're looking at the squared term up here. And we call this exponent that I keep focusing on, we call it a degree. So here, the degree for a linear function is just 1, and the degree for a quadratic is 2. The shape of every linear function will be some form of a line. And the shape of a quadratic will always be some form of a U. Now we'll get here later on in the chapter, we'll get to where we can transform these functions and move them around and turn them upside down. But just in general, here are the general features of each. So when I'm trying to classify these functions as linear or quadratic, what I'm looking for is the x value. Does the x value have a 1 or does the x value have a square? Also, I need to be wary of if I see more than one x term, what am I doing in the x terms? Am I adding them or am I multiplying? So we look at this here, look at example 1. We look at just the x value, and notice that here, your x value is 3x. It has an x of just 1, so this is a linear function. We look at b, you have 2 x's, but you're going to focus on the one with the 2 on it this time, because that's the higher of the 2. And that's the degree, so this is a quadratic. Notice here, you have 2 terms. You have an x and an x. And what's going to happen here is because you're multiplying these 2 terms, when you distribute, like here, x to x, you're going to get an x squared term. And because you're getting that x squared term, this here is a quadratic. This right here has a single x inside of here, right? This has a single x inside, but notice that you're squaring it. So what does x minus 5 squared really mean? That's x minus 5 times x minus 5. And again, from what we saw in C, because of this, when you distribute this out like this, you're going to get that x squared. So this is also a quadratic. Here, focus on just the x, even though you have all these different terms over here. And we focus on just the x term. It's a single x. There's no other x's here. So this is linear. And this last one is a special case. When y equals 7, well, y equals 7, you might need to graph it to look at it, but when y equals 7, it looks something like this, and we can see that it's a line, so this will also be linear.